Hi guys, this is Miss Singh. I've been getting a lot of questions about the science article, and maybe your science teachers aren't uploading it for some reason. So I'm going to go ahead and read it to you, and that at least will give you some idea of what you're doing. And then I will also upload this article to Google Classroom. So even if your science teacher hasn't, then you'll have access to it. So, by the way, it's been really nice to see you guys on Zoom and talk to you. And I know I've talked to a few of you on just like one on one on the phone. So, that's been really fun too. So, anyway, let's just jump into it. This is a higher level of reading. So, if you struggle with some of the words, that's totally fine. We're just trying to push you guys and get you more, exposed to words that are going to be helpful in 8th grade and high school. So, this is magma's role in the rock cycle. So I really do like that we studied Moana. I wish we could have gotten into more of this part of it because it does tie in a little bit since they talk about the different like volcanoes and things like that in the movie, and Maui and how all that kind of stuff. So I just think it's kind of a connection here. So anyway, magma's role in the rock cycle. Okay. Magma is a melted and partially melted rock mixture found under the surface of the earth. This mixture is usually made up of 4 parts: a hot liquid base called the melt, minerals crystallized by the melt, solid rocks mixed into the melt, and dissolved gases. So it looks like you have melt. This is making me want a grilled cheese sandwich, by the way. So you've got melt, minerals, solids, and dissolved gases. So those are the four parts. When magma is ejected by a volcano or other vent, the material is called lava. So when it's inside the volcano, it's called magma, and when it's outside, it's called lava. Magma is extremely hot, between 700 degrees and 1300 degrees Celsius, or 1292 degrees and 2372 degrees Fahrenheit. So a lot hotter than Bakersfield. This heat makes magma a very fluid substance. It is able to create new landforms and engage in physical and chemical transformations. So this is super cool. When we think of going to Hawaii or something like that, we just think of the trees and the beautiful flowers, but really it all starts as this hot liquid. And then when the hot liquid pours out of the volcano, it solidifies and becomes this really cool volcanic rock. Which, by the way, for those of you that like gardening and things like that, we don't have anything like that here, but if we did, it's such a good soil to have for things to grow. And that's why Hawaii is so beautiful and green and lush, is because this rock that comes from the inside of the volcano as magma and lava is so healthy for plants. So I just think that's really cool. Anyway, let's find out how magma forms. So Earth is divided into 3 general layers. The core is the superheated center. So we have the core, the mantle is the thick middle layer, and the crust is the top layer. So that's easy to remember. Obviously core, like core of an apple, is the middle. Then you have mantle, which is the middle layer. Think of it as like a shelf. You sometimes call shelves like a mantle, like a fireplace shelf is a mantle. And then crust, like a PB&J crust, is the top layer. Magma comes from the lower part of the Earth's crust and the upper portion of the mantle. Difference in temperature, pressure, and structural formations in the mantle and crust cause magma to form in different ways. So it looks like we've got a picture here of the inner core, outer core, convection cell, I think that says, and then you've got the ocean and things like that. So let's figure out how it forms in different ways. One is decompression melting. Decompression melting involves the upward movement of Earth's mostly solid mantle. Hot material rises to an area of lower pressure. Areas of lower pressure have a lower melting point. This decrease or lowering in pressure or decompression allows the mantle rock to melt and form magma. So, this is a little confusing for me too, since I'm not a science major. But it sounds like because the pressure, just like when heat rises, I guess it's being pushed upwards. That's my guess anyway. So this is new for me too. Decompression melting often occurs where tectonic plates separate. Their movement caused the magma below to float up and fill the space of lower pressure. The rock then cools into a new crust. I guess the best way I could explain that is, like, let's say that you are let's say you're making a grilled cheese, and you know how if you were to like bend the bread, the cheese would kind of like bubble up and then it would get more solid. So like the liquid cheese would kind of come up and then it cools and it becomes a little more solid. I guess that's kind of what's happening. The second part, or the second way, is a transfer of heat. So magma can also be created when hot liquid rock intrudes into the Earth's cold crust. As the liquid rock solidifies or it becomes solid, it loses its heat to the surrounding crust. Like hot fudge poured over ice cream, this heat transfer can melt the surrounding rock, or like the ice cream, into magma. Oh, so that's really cool. Okay, so if you took ice cream, which is cold, and you put a hot fudge, it's going to melt some of the ice cream, right? So that's kind of what happens too. This liquid comes up, and then it causes the earth to kind of turn into some magma. Heat transfer often happens where tectonic plates are crashing together. As the denser tectonic plate subducts, if we look at the English root there, sub means to go under, so it sinks below. The less dense tectonic plate, hot rock from below, pushes into the cooler plate above. This process transfers heat and creates magma. Okay, the third way is flux melting. Flux melting occurs when water or carbon dioxide are added to rock. These compounds cause the rock to melt at lower temperature. This creates magma in places where it was originally solid. Okay, so this looks like... All right, I'm trying to understand this too. So it appears that when you're adding that water or carbon dioxide to the rock, that means it's lowering the melting point. And then this creates magma in places where it was solid before. Okay, so when you've added that carbon dioxide and water, it's making it easier to melt that part of the earth, which is really interesting. It says, like heat transfer, flux melting occurs around subduction zones. Again, sub means under. Water overlying the subducting seafloor lowers the melting temperatures of the mantle, generating magma that rises to the surface. Okay. So now you have to think, so you've got these 4 different ways, right? You've got your decompression melting, transfer of heat, and flux melting. And now you have to think about, how does the magma get out, right? If you have, again, almost if you think about that like grilled cheese or something that's real hot in the middle, when you start breaking it, it wants to come up, it wants to get out. So it says magma leaves the confines of the upper mantle and crust in 2 major ways. So we have intrusions or extrusions. So intrusions occur within the Earth's crust. They can form features such as dikes, which are large slabs of magmatic material that have intruded into other rock bodies. Intrusions can also form xenoliths, which are pieces of rock trapped in other types of rock. So I don't know if any of you have had the horrible experience of having somebody maybe try to break into your home. That actually happened to me as a kid, and it was really scary. But we would call that an intrusion, right? So it's when something is trying to get in that shouldn't be there, or trying to get in. So it says here, you've got pieces of rock trapped in other types of rock. So the magma is trying to get in. Extrusions or exit form above the crust surface. So the most familiar way for magma to escape, so if you think about exiting and escaping, is lava. So lava eruptions can be fire fountains of liquid rock or thick, slow-moving rivers of melted material. Magma can also extrude into Earth's atmosphere as part of a violent volcanic explosion. So that's the really fun ones to watch. If you've ever seen a video, you should just go to YouTube and type in, magma and lava and things like that, and you'll see some really cool stuff. Okay, so we're getting through there. This is a longer article, but hang in there with me, guys. So magma chamber. In some places, magma collects in magma chambers. Most magma chambers sit far beneath the surface of the earth. So as you can see from this picture here. In a magma chamber, the least dense magma rises to the top of the magma pool. So if you think about being in the swimming pool this summer, how you have certain things that will sink. I don't know about you, my family, they used to like throw a quarter into the pool and you'd have to dive and go find it because it sinks, right? So it's more dense. it sinks. But if you throw like a pool noodle, if you try to push a pool noodle under the water, what does it do? It floats right back up, right? Because it's not dense. So the densest magma, like the quarter, sinks near the bottom of the chamber. And then over millions of years, many magma chambers simply cool to form large igneous intrusions. So again, intrusion, right? You've got somebody kind of breaking in to the pool. So if you leave that quarter at the bottom of the pool, it's just going to stay there, right? And so this magma that's very dense, it'll fall to the bottom, and then it collects more, and it just becomes like a big rock at the bottom of the ocean. Many volcanoes sit over magma chambers. If a volcano's magma chamber experiences greater pressure, the volcano may erupt. Any eruption reduces pressure inside the magma chamber. In a violent eruptions, the volume of magma shrinks so much that the entire magma chamber collapses. Okay, so there's different types of magma. As oxygen and silicon are the most abundant, or there's many elements in magma, geologists define magma types in terms of their silica content. Differences in chemical compositions, or how they're made up, are directly related to differences in gas content, temperature, and thickness. Okay, so obviously if you have something made up of different chemicals, they're going to be different in what they're made of and their temperature and thickness, right? Ice cream is going to be a different temperature than tomato soup, so depending on what it's made of. Okay, so there's mafic or mafic magma. I'll have to ask my husband how you pronounce that, but let's say mafic. So mafic magma has relatively low silica content, roughly 50%. This type of magma has a low gas content and is less thick. Mafic magma also has high mean temperatures between 1,000 degrees and 2,000 degrees Celsius. Decreased thickness means that mafic magma is the most fluid. So this is the most runny type of magma. It erupts non-explosively and moves very quickly when it reaches the Earth's surface. So it's real runny. Like, let's say it's like broth, chicken broth, right? So that's not going to erupt that much. It's just going to kind of flow out very easily like water. Okay. Then we have intermediate magma. Intermediate magma has higher silica content than mafic magma, roughly 60%, and this results in a higher gas content and greater thickness. Its mean temperature ranges from 800 to 1,000. So if you look, it's actually less hot, but it says it's thicker. So as a result of its greater thickness and gas content, intermediate magma builds up pressure below the Earth's surface before it can be released as lava. This lava tends to explode violently. So that's the real fun one, right? So it's not as hot, but it's real thick. So it'd be more like if you had, I don't know, maybe instead of chicken broth, maybe you have something like potato soup, or you have something that's a bit thicker. And that's going to build up this pressure and build up, and then it blows up. Okay, then we have felsic magma. Felsic magma has the highest silica content of all magma types, between 65 and 70%. And as a result, felsic magma also has the highest gas content and thickness, and the lowest mean temperature. So again, this one is cooler, but it's even thicker. So instead of potato soup, maybe it's, I don't know, I'm trying to think of something thicker than potato soup, but it'd be a lot thicker. So it's thick, slow-moving felsic magma can trap gas bubbles in a volcano's magma chamber. These trap bubbles can cause explosive eruptions. Felsic magma is most commonly found at convergent plate boundaries, where heat transfer and flux melting create large volcanoes built of layers of hardened lava and ash. So again, mafic is real thin, runny. Intermediate is, more like potato soup. And then you have felsic, which is real thick. Okay? And if we're looking at the silica content, this is low, medium, and high. But if we're looking at temperature, you're going to look at high, medium, and low. And also, sorry, I guess my husband's game's up. So there you go. All right. Okay, so then these are your questions for science. So I'm not going to get into that. You just need to look at the directions for, just the article for me. One more thing before I let you guys go is here is my assignment for you. So it just says read the article, which we just did, and you're going to answer in a 2-chunk. Okay, no banned words, no I, me, you, we, none of that. Please cite your source, just the page number. Okay, so it says here comparing and contrasting decompression and flux melting. How are they similar? How are they different? So really quick, I'm going to go back and have you, we're going to look at that real quick so that I can let you go, okay? So decompression and flux. So let me pull that up real quick. If I can find it here. Oh, right here. Okay. Decompression and flux. All right, here we go. Very easy. So decompression melting involves the upward movement of the Earth's mostly solid mantle. Hot material rises, right? Like that grilled cheese. You break open a grilled cheese, the cheese wants to come up and out. It's not going to just stay in there. Areas of lower pressure have a lower melting point, and this decrease in pressure or decompression allows the mantle rock to melt and form magma. Okay, this happens where tectonic plates separate, and their movement causes the magma below to float up. Again, you break that grilled cheese, it's going to come up through the holes, and then it's going to cool into a new crust. That's decompression. Flux melting occurs when water or carbon dioxide are added to the rock. These compounds cause the rock to melt at lower temperatures. So you're adding water and carbon dioxide, and this creates magma in places where it's originally solid. So it says here these happen in subduction zones. Okay, and again, you're adding two things to it, which causes it to the heat capacity or the heat limit to lower, so it can become hotter, if that makes sense. So that's all I'm asking about: decompression melting and flux melting. Okay, if you're feeling, confused, I will try to look for a YouTube video that kind of explains it a little bit more, maybe with some videos. But other than that, thank you guys for sticking with me. I know it's kind of a longer video. But I'll go ahead and stop that now, and you guys can email me if you have any questions, okay? All right, you guys, take care.